Protecting and preserving our oceans is vital to future generations. In order to do this effectively, we need persistent monitoring on water conditions and close analysis of ocean trends. This is a difficult and cost-prohibitive challenge, considering our oceans cover more than 70% of the Earth's surface. How can we afford to maintain and staff the ships necessary to collect high-resolution data throughout the world's oceans? Now there's a new tool revolutionizing ocean data collection, the iRobot Seaglider Unmanned Underwater Vehicle, or UUV. Seaglider cost-effectively performs a wide variety of data-gathering missions for oceanographers, researchers, and military planners. This UUV can collect physical, chemical, and biological oceanographic data and perform persistent surveillance and marine environmental monitoring and a variety of other missions, all for a fraction of the costs of traditional manned research vehicles. While saving you money, Seaglider also enhances your data-gathering efforts in a number of other ways. Seaglider performs extended data-gathering missions that last many months and cover thousands of kilometers, both in shallow water and the open ocean. At times, Seaglider has successfully operated through tropical storms, typhoons, and hurricanes. The real-time data Seaglider gathers is sent to your desk or smartphone from anywhere in the world. The U.S. Navy, government agencies, along with universities and research organizations worldwide, all rely on the Seaglider for their underwater exploration needs. Seaglider is designed for global data collection. Diving down to a maximum depth of 1,000 meters, this UUV gathers data on missions that last up to 10 months and cover thousands of kilometers. Seaglider receives commands and sends back data on a programmable schedule using global satellite communications. Seaglider supports a wide variety of data gathering missions in a range of ocean environments, such as marine environmental monitoring, which helps our marine scientists help save fish and endangered sea life. Hydrocarbon monitoring, which helps monitor oil spills and pollution. Persistent monitoring. Physical, chemical, and biological oceanography, which helps us understand climate change. Tactical oceanographic surveys for maritime security. Water quality analysis, and measuring temperature, biological activity, conductivity, oxygen, turbidity, and other quantities in the ocean. During missions, Seaglider is controlled by satellite communications from a base station that can be located thousands of kilometers away from the mission site. From any internet-connected device, the pilot can log into the base station, monitor the UUV's progress, send new commands to the Seaglider.
We should send the glider back here.
And review data collected by the glider.
The salt oxygen concentration.
At the end of a dive sequence, Seaglider comes to the surface, raises its antenna out of the water, and contacts the base station via Iridium satellite phone. Seaglider uploads the oceanographic data it has just collected and then downloads the next set of operational instructions. Once the data transfer is finished, Seaglider slips back under the surface to begin its next dive, piloting itself to the next waypoint through a compass heading. Unlike other UUVs, Seaglider does not need to be reconfigured, recovered, or reballasted between shallow and deep water dives during the same mission. Seaglider operates efficiently both in shallow water and as deep as 1,000 meters, making it ideal for all types of missions. Seaglider's various modes enable it to perform the jobs done by a variety of devices, including Argo floats, environmental buoys, and bottom sensors. To start a dive, Seaglider changes its buoyancy by deflating the external bladder in its aft section. Seaglider shifts its internal masses, providing both pitch and roll control for maneuvering. When Seaglider gets to the desired dive depth, the battery pack moves back to pitch the nose up, the bladder inflates once again, and Seaglider begins its ascent to the surface. Multiple sensor ports allow Seaglider to simultaneously accommodate sensors that measure conductivity, temperature, dissolved oxygen, optical backscatter, and a wide range of other ocean quantities. Seaglider's expandable open interface also makes it fast and easy to integrate additional third-party sensors. Seaglider effectively gathers data in a range of environments around the world, performing missions in fresh and salt water, in the tropics, and even under polar ice. To allow for continual monitoring and analysis, and to guard against data loss, the Seaglider pilot sends commands via satellite to the UUV and receives back data on a programmable schedule. With Seaglider, you get high-resolution, real-time data you need in a very cost-effective manner. iRobot provides hands-on Seaglider training courses to teach you how to accomplish your research goals. Through classroom instruction,
The course objectives.
computer-based training,
As the glider began its descent,
and field exercises, you will learn how to operate and maintain this UUV. Instruction includes on-the-water launch, recovery exercises, and piloting. Gathering ocean data is expensive. With manned research vessels and moored instruments, costs can run as high as $50,000 per day. With Seaglider, you gather data for a fraction of the cost of traditional methods, and the cost savings add up fast, especially during long-term operations, such as catastrophic oil spills. During the Gulf of Mexico oil spill in 2010, researchers were working around the clock. While the world was watching the devastation, Seaglider was working far below the surface, monitoring dissolved oxygen levels at depths of more than 3,000 feet. Seaglider autonomously monitored the Gulf waters day and night, transmitting valuable data back to researchers for analysis every few hours. The successful mission in the Gulf resulted in a big idea: using a fleet of Seagliders to persistently patrol the entire Gulf area, ready to detect ocean properties such as oxygen saturation and biological activity. Persistently patrolling the Gulf of Mexico and other areas of the ocean is just one of Seaglider's potential applications. Seaglider is the UUV oceanographers need to perform a wide variety of efficient data collection missions. For months on end, over thousands of kilometers, through the most severe weather, the Seaglider will reliably perform extended data gathering missions, both in shallow water and the open ocean. With Seaglider, you get more of the data you need for less cost.